I've talked a lot about 3-minute and 6-minute cycles.
Yes.
In relationship to the solar system particularly. And I've also talked about 1860 minutes. And these all show up also in human activity and other things related to humans. For example, people talk about the 90-minute sleep cycle. You come up into a REM state and then back down to deep sleep in about 90 minutes. In actual fact, when you see examples of these, the average is a bit over 80 minutes. And when I talk about the 80-minute cycle, it usually means slightly over 80 minutes. So that's cycle showing up in our behaviour patterns. In this case, we're looking here at the rate that blood sediments in a centrifuge. And it's being measured by a laser, measuring it very accurately in short periods of time. So this is a period of 2 hours.
Yes.
And this is plus or minus rate at which it's sedimenting. And we can see it starts off with a few things happening, and then it settles down to this bip, 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 bip at 3-minute intervals.
Yes, indeed. And you know, it's interesting, if you want to look at it as a social aspect, if our behavior is reflecting wave activity, about popular music. When you look at the popular music you will listen to on the radio, this goes all the way back to the days of AM radio being where it's at. We're from the 1950s. Popular songs were required to be 3 minutes.
Yeah.
Interesting.
Yeah. Then you're ready for another cycle. Now, to go further with this blood sedimentation, when they do this in the centrifuge, it takes some amount of time for the process to complete enough to separate the parts of the blood that they use, do different tests and different things on. Mm-hmm. And these data are available all around the world on these things, and they do tens of thousands of these things every day in lots of countries.
Yes.
And so someone began to look at them, and they found the rate at which blood sediments, if you plot it on successive days, it may go a bit less, a bit less, a bit less, a bit more, makes this very interesting graph. It wanders about by 100% or more over a period of a week or two.
Yeah.
And then someone said, well, is it a local phenomenon? So I looked at different cities, different countries, different things. They were all doing pretty much the same thing. So that becomes clear that the rate of human blood sedimentation is affected by cosmic factors. It might be the sun, it might be the moon, it might be something much further away, but there are some things that are passing through the earth that are affecting the rate that human blood sediments. Now, that's if it can affect blood that's come out of the body, it can presumably affect blood that's still in the body. So those things, so we as organisms are affected by cosmic factors that are not the obvious things that we see, like sunlight or the temperature or the pressure and all of that. There's some other things that are going on that we don't see. Remember, when we talked about the senses, most of the stuff that's happening we don't see. We only see a very narrow range of sight, a narrow range of sound, a narrow range of this, narrow range of that. So there's a lot of stuff going on that has effects on things that are outside those ranges. There may be extremely high frequencies or low frequencies, we don't know.
Yep, ultraviolet, infrared.
Yeah. So there's some more things related to that. Let's think. Piccardi, an Italian man, and when I went to university, you did physics experiments and you expected to get the correct answer.
Yeah.
When you did chemistry experiments, you sometimes got a bit of a different answer, even though you reckon you did it more accurately than that.
Yeah.
And the popular name for this amongst people in the chemistry department was, it's Cook's constant.
Okay.
You know what Cook means? Fiddle.
Yes.
And so it was sort of recognised that chemistry was a bit like that. And some experiments are more like that than others. And this guy Piccardi started to look for the ones that are most like that.
Yes.
And he found some experiments where it was a delicate balance of whether sometimes you can make this thing run one way, and then you can make it run back with some other thing. And he decided that because this thing ran at different speeds, this chemical reaction, it must be due to some cosmic factors like this. This is a long time back. This is middle of last century, I think.
Yes.
And so he decided it's something that's coming from outer space or somewhere, the sun or something. So he checked for temperature, he checked for pressure and all of that. Then he started going down into the dungeons, down below the earth, to try and block out all these things.
Yeah.
And he found out that when he went 60 feet down, The reaction I think ran a different way at day and night. It went back and forwards. He went down there and he found it didn't do anything. It just stayed constant.
Oh.
When he brought it up halfway there at about 30 feet down, the reaction would run one way and then not the other. So it was that amount of Earth was blocking out whatever the cosmic things were, neutrons or some sort of electromagnetic radiation or whatever. But there's a lot of stuff going on that we don't see. Yeah. Some things are more sensitive to it than others. Yep. Certain chemical reactions are more sensitive, and life, to operate, it wants some things that are in delicate balance. It can just tip this way or that way to make things happen, and that's how all these things happen on in here and stuff around our body. Yeah. It's got to be able to do this and that and this and that and this and that. So this sort of thing that we see is telling us something about how the delicate chemical reactions of the body are subject not just to being able to adjust it by the body itself, but by cosmic forces.
So we're not just sitting on a rock, autonomous, amid empty space, because space isn't empty and we're not immune to it.
No. In the mid-1990s, I made a trip to Russia. It was I was introduced to them by a fellow Thomas in America, who was studying voltage levels. He argued with his university professors about voltage. They said voltage is always relative to something else, and he didn't accept that. He thought there had to be an absolute one, and he proved in the end that you could measure things absolutely. And when he did that, he found the surface of the Earth fluctuated by hundreds of thousands of volts over a period of weeks. And so because I expressed some interest in what he was doing, he expressed some interest in what I was doing, and he said, I think you'd find these people in Russia that I've been doing stuff with would be interesting to you, and you'd be interesting to them. So he put me in touch with them, and I began to communicate. And they were measuring the rate of decay of plutonium. Now we're always told that radioactive decay is a totally random event. Each atom randomly goes off at some point. If we sit and think about that, you're probably going to decide it's wrong, but at any rate, that's the standard theory. And they measured these in each minute. They would count from the sample how many detections they got of things decaying. Then they do the same the next minute, the next minute, the next minute, and they've been doing this for 18 years. Somewhere along the way they started doing it each second, and then somewhere along after that every 60th of a second or 18th of a second or something, and they had all these data. So I said to them, could I get some of your 1 minute data for a period of time, because I think there will be some cycles in there of 3 minutes and 6 minutes duration. And they said, no, there aren't any cycles of that period. We've analysed the cycles and we have found some cycles, but not those ones. And I said, well, I'm going to do the analysis a different way to you. Could I have some data? They said, yes, sure, and they sent me some data. Now, the things they'd already found were, they'd found one cycle of 24 hours, they'd found another cycle of a lunar month, and a cycle of a year. They weren't just in the number of decays, they actually made a histogram. Each minute, at the end of an hour, they'd put the 60 ones they'd got, and make a histogram of it, and it might look like this. And they would make that histogram, and then they would do that for every hour of the day. Then they would compare the different hours, and they would find, even when people didn't know which was which, doing a blind comparison, they found that adjacent hours were more similar to each other than ones that were, say, 7 hours apart. And that after 24 hours it became more similar again, and after 48 hours. So they found there were these cycles, and did the same with the month and the year. Later on they showed that the daily cycle had both a 24-hour component and a 23-hour 56-minute component, and that's the sidereal day, right? That when we come back to the same point relative to the stars, the other one relative to the sun. So they had found those cycles in it. And so I got this data and I analysed it, and I used the method you've seen me use sometimes before, which is lagged correlations. So you take the data, you compare it to itself, then you move it, in this case 1 minute, and you do a correlation. Then you move another minute, do a correlation, another minute, do a correlation. And out here you plot the time difference in minutes, the time lag in minutes, and how much it correlates. And what you find is you get something that goes like this.
Yes.
And that period was 3 minutes. Both the 3 minute and the 6 minute period were present, yes. After which it tended to come back to a similar state. Now, if you go a long period of time, once you get to about 20 cycles, this thing fades out.
Yes.
So it's not a strictly rhythmic exact clock. Incidentally, a similar thing happens a bit with sunspots. That reduces, although it does come back up again.
Yes.
And so what it's saying is, yes, there's an oscillation there of about 3 minutes, but it's not like a clock ticking. Its phase wanders around a little bit, and the amount it wandered around a bit was about 5%. So that's why after about 20 cycles it would lose synchrony with it. And the same with 6 minutes. Now, they were having a couple of conferences over in Russia, and I went over there to go to. Well, I went to 2 conferences, one in Crimea and one in Stavropol. And also I gave a couple of seminars, one in Pushchino, which is where the main laboratory was of the Russians doing this work, headed by Simon Schnoll, and there was also there Natalia Udovtsova, who had been in communication with me, and some others that I met there. And then we made a trip up to Moscow University where I gave a talk as well. When I gave my talk at Pushchino, they said, we've been reading about your stuff. Oh no, the first thing that happened is when I arrived, Natalia said to me, I want to show you something. She said, you had however many days or months it was of work of the data that you found this in. She said, I've gone through the entire 18 years and we have a program that does something very similar to what you were doing. Yes. And it does, it's what I call a voice print. You have time running this way and frequency this way, and you make it darker where there's a strong frequency is present. Yep. And she'd gone through, and there were these 2 bands at 3 minutes and 6 minutes just running right through the entire thing, and she went time by time. It was right through the whole thing. So she said, yes, there's a 3 minute and 6 minute cycles there, all the way through the data, exactly as I predicted at the start. And I predicted those cycles because the inner solar system, I believe there's that wave running through the inner planets, a standing wave from the sun. The sun has oscillations around 5-6 minutes, and so this would be connected to that. So I went to these couple of conferences, and I gave a talk in Pushchino, where they had a bunch of physicists there. I'm talking away in English, and they're all listening in English without a translator. And just occasionally one of them would say something in Russian to one of the others, and I'd be waiting for them to translate it into English so I could answer the question, and then they'd say, carry on, and I'd say, what happened? Oh, he had a question, and he's explained it to him. They were understanding. They were all going along, and then at the end, they had a little discussion, and I was very pleased. Simon Schnoll said to me, before you came, we thought your work was very interesting, and there might be something in it. He says, now we've discussed it, we all agree there's something in it. So that was good. I haven't, and then I said to them, I don't get that good a reception from physicists in America. I get a very different reception. They're very closed-minded about it, and I said, why would that be? And they said, it's the what is it they get? They get to stay at university.
Tenure.
It's the tenure system, and they said, well, they'd been under communism until here. And it was pure research. It wasn't, you had to pay your way with this and that and the other thing. And so they said, that's changing now, the fall of communism, that's changing, and in a few years ours is going to be like the American system. It's going to all be lost. And I did see that there with a couple of the people I met. They had to give up doing pure research and had taken up doing computer programming or something where they can make a lot of money. So Natalia, who's coming to visit me in a couple of months with her husband and the kids, he had stopped doing the research and started doing computer work to pay the way, because they had frozen salaries, but the value of the currency was going down and down and down. So you were doing it for the love of it, and that was all.
Yes.
So those ones, they've gradually improved the methods on their analysis of those cycles for the year and so on. But it was a long time before the West began to catch up with this. There's a lot of things where the Russians are ahead, because they read the journals that are in English, and they read and write the ones in Russian. But the Westerners just read the English ones, they don't read the Russian ones. So unless something gets put in there, they don't know about it. And it was years later that about a tenth of what they had done got published in the Western journals, saying that there is a 1 year cycle in the rate of radioactive decay, and they attributed it to the fact that the Earth had elliptical orbit and was further away and closer at times, and that's probably quite likely is a factor in the cause, because the moon's orbit and the alignments and things, these things I think it is related probably to gravity in those alignments, but that's happening. We can't say for sure, but it's certainly a cosmological factor. It's definitely connected to the sun and the moon and the Earth's rotation. So, so there's a little bit of that in the West now, but if they read the work of Simon Schnoll, some of which is published in English in some journals, and the biophysics laboratory there, it would advance their thinking quite a bit.
Wow. Thank you, Ray Holmes.